Oh, hey, William. Doing some metaprogramming stuff. How did you even find this? That's interesting. Yeah, that's cool though. Yeah, that was just unexpected. So basically, I'm doing some metaprogramming stuff with C++. I basically wrote a parser for C that spits out a syntax tree of your code. So I can just run that really quick. You can just see what the tree looks like. So I just have this simple main that has some structs in it and just a main function. It does some other stuff behind the scenes for some of these function calls, but you can see I'm just calling a couple prints and a function here. And the tree it generates is, well, the tree's kind of huge, so so here's the tree for that main file. There's the two imports. There's a struct, right? Another struct. Here's the main function, right? So it just generates a tree of your whole program, and then you can write meta programs that can look at and modify and do stuff with this tree that then spits out a final source file, which looks like this. It's this crazy source file with a bunch of line directives to the different files. It spits it out from that AST. So this CPP file that gets generated is ultimately what you compile. But a lot of this code can be generated from the metaprogram, the AST. You can modify the AST, generate your own functions and stuff, and then it'll spit it out to this file. So for example, like these print functions are totally generated. Like I basically look over the whole tree for like any structs or anything you have and generate these print functions for them so they know how to print them out without you having to write it. That's just like one example, but I'm glossing over a ton of code, but hopefully that makes sense what's happening there. And the reason this final file looks so crazy with all these line directives is because then you get proper error messages and stuff. So like if some random function failed in generated code, this line directive in the file tells the debugger, hey, this is where it happened. So you can go look at it in the actual file. You're basically never going to be looking at this generated file. So yeah, no worries. I think it's crazy to just see your name pop up. I was not expecting that. Yeah, and I'm just like streaming for no reason other than to motivate myself a little bit to work on stuff. So metaprogramming is basically just writing code that writes other code. So I have a C program that spits out other C files that I can then compile. That's basically all it is. But with that, you get to write programs that can do a bunch of crazy logic to generate files for you. Oh, I am? That shouldn't be happening. Hold on. Cool, thanks, William. Okay, there. I should no longer be in your left ear. Thank you for letting me know. I just set all this stuff up, so. I'm doing good. I'm streaming on YouTube also, so sometimes I'm talking to people and they don't line up. But yeah, I'm just streaming to motivate myself to work a little bit more. So, and plus, I'm just excited about the stuff I've been doing. So, it's fun to show it when possible. I'm trying to get into a habit of doing it more, so we'll see how that goes. Yeah, this is Arch right now. I'm pretty much in Linux all the time, so that's where the that's where the majority of my streaming will be happening. But the setup, like, it's hard to tell because the actual editor will be the same on all of my places. So unless I'm debugging or something, it'll be hard to tell. But yeah, and if you're curious, I'm just running i3, so it's just a. I do tend to keep it pretty minimal though, so like there's not a whole lot to look at, which you know. And actually, wait, that can just come straight from the node, can't it? I do, yeah, why? Like, I run i3 as my primary desktop, so everything I do is in i3. Yeah, I have had no issues whatsoever. For when I first built this new PC last year, I finally decided to try Wayland and had nothing but issues on Sway. I went to Sway, and I installed my old stuff back on there, which is i3, and it's been fine. I've been running i3 for almost 10 years now, and have never really had any issues. So. Yeah, I do run, so the transparency and stuff that you're seeing, so how you can like see through these windows and stuff, and like my background, I am running a compositor. I'm running Compton to or PyComp, whatever it is. I'm running a compositor for these effects, and that gives me VSync, so I haven't had any issues with tearing as long as I do that. So, and I've always done that, so without that, I'm not entirely sure how to get around that. We're passing in the output, so the output path. Let's assert that we're running this on Are we going to be running this on a source file node always? I guess so, yeah. Yeah, I feel like I should check out Hyperland, but it seems way too it seems almost like it's built to be very flashy, which is not a problem. I'm sure you can customize it to not be, but I like my setup pretty minimal. It does seem like it is far and away the most popular like tiling window manager for Wayland though, so my experience with Sway was pretty bad, so maybe Hyperland would be better. I just haven't gotten around to trying it yet. So make sure that this is a source file. And we can just grab the path from here. Is it just path? Is that what it is? Yes. Whoops. Okay. So I guess just to give you a brief overview of what's happening here, let me spit this out to a file, just so if you're curious what you're looking at here. So, okay. Oh, wait a minute. This should be on. Okay. So here's like the main code. I just have a main file, and this this started out as parsing C code for my metaprogramming, but once I got the whole AST set up and the system in place, I realized that like I could kind of just do whatever I want at that point and add more things that the parser could parse and new syntax. So it has now expanded beyond just C. So now I have this custom just DB file with some extra syntax. So like depend is a new keyword or a new preprocessor, for example. I have a few other ones like that. But anyway, it's basically just C code. I pull in some extra code here, and you can see it's just a main with some extra stuff. Yeah, I'm just calling some functions. That gets turned into this metaprogram, or the metaprogram runs and it turns it into this AST, which is an abstract syntax tree. So if I search for main, so that main file that you just saw before, here's the tree for it, right? Here's the top of the tree is the source file. Those are those two depends. Here's a struct definition, SS wrap, and it's got one member. It's a short string called SS. So you can see that's this right here. Here's main. So here's the main function. And it's just literally a tree representation of the whole program. And like I said, I'm pulling in a bunch of other files. So that's what all these ones up here are. There's just a bunch of other code. But if you just look at the main file here, this is what it generates. It generates a whole tree based on your code. And then from there, you can write metaprograms to loop over the tree. You can modify the tree. You can append new stuff to the tree. You can do whatever you want to this tree, which represents your code. And then have that, what ultimately happens is it spits out this single gigantic CPP file, which is that syntax tree spit out back into C code. So ultimately, this is what gets compiled. Here's the entire program as one gigantic generated file. This gets compiled to be the ultimate program. And what that lets you do is all these metaprograms can do a bunch of really powerful stuff to modify the code, because it's just C code you're writing to do a bunch of fancy stuff. So like, for example, these print functions are totally generated. I didn't go write print functions. So like I'm printing out, here's test, which is one of these A structs. I just say hello percent, like hello, I got an A percent, and I just pass it this whole struct. And if you look at what the output of that looks like, it's, you can see it prints out the first element and then the next element, which is this X and this whole other struct, which has a short string inside of it. That is all generated. I did not write code specifically to be able to print one of these things out. The metaprogram knows, oh, you have a struct called A. I'll generate a print function that can loop over the members and print it all out. So that's a very basic example of what the metaprogram can be doing. Is I basically will never have to write a print function ever again for my code base. They get generated every time I build my program based on what's in it. So like I can say struct F, and it has a short string A, or let's not call it A, 1 and a U64 2. And let me comment these out really quick just so you can see. So if I do F test struct dot 1 equals hello world test struct2 equals just some number, right? I can just say print, here's my struct, and I can pass it test struct. And when I print it, did I not? That's F not gonna let me do that. There, okay, yeah. So see, all I did was, I did not write anything but my struct, and now I can call print on it, and we've got the two members, right? Here's the string that I wrote, and here's the number in it. So, and that's happening because the metaprogram is looping over all the structs in my program and generating those functions to do that. Hopefully that makes sense. Super basic example of what you would use a metaprogram for, but it's kind of just the start of a bunch of other cool stuff. So and you can see here, if I go to this generated code, here's the actual function that got generated, and let me remove these line numbers just so you can see it easier. The line numbers are there so you can still debug and get good error messages and stuff. So if I just clean this up a little bit, you should never be looking at, you should never be having to look at this generated code, but there, you can see what it generated. This is literally what that metaprogram generated based on that line of code. It generated a print function that takes the format string, takes one of my structs, it calls this format string, which again, I'm generating that too, so I'm generating a format string function that takes a format at one of those, and then it just writes the output to the screen. So and right now, yeah, right now my goal is to get some of this stuff a little bit cleaner. So all of the generated code right now, I've already done the first part of it, is the nodes that get added to the AST for the generated code. I want them to behave more like actual source files, so you can go look at them as normal source. They'll show up in the tree as normal source. You can step through them in the debugger, stuff like that. Right now, none of that really works, so that's what I'm doing right now. It's just to clean up the way these things are represented. And right now, these do not have, for anything that's generated, these things do not have proper line numbers. So you can see, like, all of these, here's two constants that I define in the metaprogram. They're in this same file, they're in the primary chunk. And these two constants have the same, they're both on line 1 of this, like, fake source file. That is totally useless when it comes to debugging and getting error messages and stuff like that. So that's what I'm addressing right now. But to do that, I need to You need to figure out every time you add something to the tree. I guess to start, I can just... I want to know where these line numbers are getting added in the first place. So when I append, so that's happening in the lexer though, isn't it? Line number. Right. So the lexer is keeping track of this. So what the lexer is doing on this metaprogram is I'm running it for each source node from code. That's happening here. I'm resetting the running line number every time. Which probably shouldn't be resetting. I should be keeping a running tally of it for every chunk, right? For the chunks. So if we go to the generation queue here, every time we process one of these chunks, we have the primary chunk, which is the main source, and then we have a secondary chunk for each subsequent run. So you have your main code, it generates a bunch of source. That source it generated is the primary chunk. But now we have to run the metaprogram again on that chunk, which may spit out more code. That's the first secondary chunk. But if it spat out more code, we have to run the metaprogram on that, which would be the second secondary chunk, rinse, repeat. So every time we chunk it up like that, it's a new file. So this needs to be where we reset is yeah, thanks for stopping by. Thanks for asking questions. It's fun. Appreciate the follow. I'm going to be doing this more often, hopefully. So okay, so I guess we need a... So that scratch lexer is global. So how about we just num token the running line and column. So the running line at the very least. Let's not reset that there. Let's reset that here. We'll do it before we run the metaprogram internally. Set, because this will be a new, reset the running line number for, where's the running line number? Because here's where we get a new file, I think, I guess. Okay. Okay. Well, so these still have the same line because I guess, oh, because they probably are on the same line. They probably are on the same line. Because, yes, so if I add a new line here where I'm generating it, I think that will add a new line to it here. Primary chunk. Yeah. Okay. So now they're different. So I don't want to do that. I don't want the user to have to do that though. So add code to program. Let's do that. Add code to program. Every time we do this, create source node from code. I feel like every time we do that, I need to maybe I don't want the user to have to think about, I don't want to have to be thinking about it over here, right? If I just say, hey, add this, that should be a line of code. Add code to program, that should be a whole thing that is compiling. So after this, create source node from code creates a source file node. So they can put, right, so this will be a whole source file node. This will be a whole source file node. So these should all have new lines after them. Yes. Append. Although, how do I... Oh, this will just be, okay, I just take the scratch lexer. I just increase the running line of the scratch lexer, I think. And reset the column. I think. Primary chunk. No, because now these are all. Oh, but these are probably generated together. So, is it here? That seems weird to me though. Because now, this will work. Yes, those are different lines. These are not though. Why? So how are those being generated? Wait, toString. Is that in print? Is that being generated here? No. Where are those being generated? There has to be a toString. Get type name from, replace type, generate function templates. Oh, that's happening here. Yes, toString. Okay. Function decal. Add function decal to program. Add node to program. Add node to program. Oh. Okay. Okay. This needs to happen here. So result is this. If result, do this. Return result. Okay. Now we should be good. Primary chunk. 87. Okay, those are definitely different than they were. Okay, now these have their own lines. Okay, great. The problem is those aren't going to line up when we spit out the file. Because oh man, I guess I don't know how to get around this one. Well, I'll keep going. I'll spit out these files and just see what they look like. Because until then, I'm not going to know what I need to do to fix this. So when we create this source node here, when we append it to the yeah, let's do that. Let's generate source file for chunk, and we're gonna pass it the we'll just do this. Pass it the, do we need the parser? I don't, generate, I guess we do, we want its arena, so create string builder. Okay, we want to do all of this. This does it for the whole AST. This does it for the whole AST, but we want to do it for just a, so this like loops over all the source files. Right. Oh, I want this to be one function. Generate source file. Instead of the parser, we will pass it AST. We'll pass it an arena and an AST. The problem is now, instead of looping over, we only loop if they gave us a root node. Otherwise, so we want to do this. Okay, hold on. So forget the root. We're going to say if AST type equals AST root, we'll do this. Else if AST type equals a source file, let's just write this the dumb way and we'll figure out if there's a way to make it cleaner after. So if the AST Okay, so if the AST is a source file, we'll just do that. Pass in the arena. AST, okay. So, oops, I have too many. Okay, so if it's a root node, we want to loop over all the source files and do this. If it's just a source file, we just want to do this. So all this is doing is saying, here's my global scope, here's the file I'm doing it in with the path. So why am I passing the path in though? Because okay, that's fine because it might not match up. That's fine. I want this to be cleaner, so how could I do? So this is not the root anymore. This is just the AST. Okay, let's do something a little wacky here. We're gonna say num children equals 0. If it's a root, then num children equals this. Okay, so we're going to loop over the number of children. So if we are not a root node, this is only going to happen once. Okay. How many times are we doing this actually? Is that just happening the one time? I may be overcomplicating this for no reason. Okay. Build. Okay, I'm being stupid. We're only building these global lists once here at the start, so that doesn't matter here. Down here, though, once we have it, okay, we're actually fine. I made this way more complicated than I need to. Generate type-dependent source on the arena builder type-dependent list, and we're going to build the string. Okay. Am I saying parser anywhere else here? No. All right, hold on. This might just work. So 3060 missed a comma. File was not declared on 3080. You're right, it's not. This is the AST itself. Generate final source file. Okay. Generate final source. What am I calling that? Oh, this is in the main. This is not final source file anymore. This is just a source file for the whole parser. No, this is the this is the output arena and the parser's AST. Nope, this is I have the actual parser here. Yeah, I have the actual parser. All right, the fact that that's still compiled makes me very happy. All Are we still working though? We are. Okay, great. So now this function can spit out a for any AST. So if it's not one of these two things, can only generate source code for an entire AST or individual for an entire AST or single source file. Got. And this will be let's write the message out here. No, let's not. We got a what is it? String for node string. What is it? For node type? Oh god, what is it? No, oh, node type strings. Parser node type strings. Parser node type strings for AST type. Early exit program. Okay, so can only generate nodes for that. We got one of those. Should still work. And if I try to pass in, like, this can literally never happen, but generate source file. We'll just say, like, its first child. Wait, the oh, the first child is a source file. So it worked. It only, okay. There we go, okay. /n. So error can only generate source code for an entire AST or single source file. Got a preproc snippet. And also, why are we seeing no colors? Do I have... Did I break something, or do I just have them turned off? Oh, that's mine. Hold on. Does Tmux not show me the colors in there? Oh, it's Tmux. Okay. Whatever. Whatever. Okay. So that's fine. Okay. Let's go back to where we were. Okay. So now we should very easily be able to generate source files for every pass of the metaprogram, like every chunk. So when we run metaprograms, for every one of these, we want to right. generate source file for chunk. So here we're going to say generate source file for chunk, parser, primary chunk. Now we're also going to do it down here for you know what? Let's do the same thing here. Let's not add it if it just didn't generate anything. There's no reason to. This is this secondary chunk. This should be primary. Okay. Should still work. Oops, what'd I do? What'd I do? I broke something. We run it on the primary chunk. We append it to the AST. What did I do? Okay, there's the code. It's there. Print the tree. Secondary chunk. Primary chunk. It's there. What did I do? Format string was not declared. What did I do? Let's go back. Okay, what did I do? How did I screw this up? This is the exact same thing. Create node. Okay, let's just remove this and go back to doing this. Create child node, parser AST source file 0. Okay, that works. This though does not. Okay, why? What happened? Append child. Why is this not the exact same thing? Create child node. Create child node. I'm calling create node. Okay. Append child. What is happening? Oh, is it? Well, no, because that has its. What am I missing? We run all the metaprograms. We have the chunk. We append it. We run all the metaprograms. We append it. What if I get, this should not be a thing that matters. No. So in one case, we next free child ID, we create the node, which just pushes it. Okay. Results parent is the parent. The parent's children there is the results. Done. Done. There, we're saying we already have the node. It's a source file. We run on this and we output it to that source file. We run, oh, shit. Right. This needs updated now. This post pass needs to be run on, oh boy. Okay. Parsing post pass. Okay, where do we run? Oh boy. Okay, this needed to get taken care of, and now it has to be taken care of. This should not get run on the parser. This should get run on a this should get ran on any new nodes should get run on any new nodes, but it should have the context of the entire AST. So post pass on, we're gonna run it on target, but it wants the context AS. No, the do I just call it context? I'll just call it context. That's not what it is though. It's the it's the target AST and the full program AST. So in this case, actually, parsing post pass, we're gonna always just pass this the parser. We are gonna pass the parser because that is the context that it wants. There's the parser, and here's the target AST. We'll call this AST post pass, and we're gonna do it on that AST. So this is gonna be AST post pass. We're gonna pass the parser, and in this case, it's on the primary chunk. Here, it's gonna be on this secondary chunk. I don't. Okay, we need to run we're running this multiple times here because we want, at this point it doesn't matter. Once we're done running the metaprograms, we're done. We don't have to run it another time. But once we're done parsing, we need to run it at least once on the parser's AST. Yes. So we parse the whole program, run the post pass on the resulting AST. Then we run the metaprogram. We get a bunch of new code. We run it on that. Then that might generate new code. We run it on that all the way down the line. Yeah, that should be fine. So post pass. So now this, let's just go one by one. Update macro calls. So this, we want to give in the parser and the AST. This just works. Boom. For each node of type in tree, AST. Good. This actually, I think, should just work. So connect types instead of the root. Okay, this is not applicable anymore because no one should be calling this but us. So connect types. Who all is calling this? It calls itself. We call it there. Okay, that's fine. Don't care for each child node of the AST. Connect types. Good. Good there. Connect declarefs. Again, we do the same thing. I think we're fine to just do this. If the AST is a preproc, if it's a snippet, we don't do it still. That's fine. Type any functions. AST. So for each node of type in the tree, we're not doing the whole parser. We're just doing the one you passed in. Yes. So all of this is no longer assuming the whole parser. We're just doing it on the one you pass in, which is, it's fine. So, that's fine. Update snippet calls. Oops. Update snippet calls. Okay, we're gonna take this and again, just don't do that. In tree, AST, and you know what? Let's while we're here, let's not yet. Let's not get distracted and do multiple things at once. Post pass. So we just did snippet calls. Replace snippet calls. Don't need that. We're good, I think. Inject defers, and don't need that for each node type in tree. AST. Okay, how badly did we break it? 740, so that's a place where instead of root, we need to call AST. Oh boy. Why? Post pass. So we call it on the primary chunk. Oh, wait a minute. Those all have to change though. Shit. Okay, it's not going to be that simple. Because this is looking in the AST, update function call if macro. Oh man, because we need to look in both this one and the main program. Shit. Okay, yeah, this is a little trickier. We want, for each node of type, we look for any pound defines in here. Wait, update function call if macro. For each node in our new tree, if it's a function call, we check to see if it's actually a macro and update it. But the places we need to check for that is now in two places. It's in our tree and the global big one. Okay. Man, this is okay. We're gonna say for each function call, update if it's a macro. We're gonna just pass the parser in always. All these things probably want the parser anyway. So at this point, we just created we ran over the AST. Primary chunk. We generated primary chunk. If we append it, okay, we can run a post pass on it after we append it. Right, we can run a post pass on it after we append it. So then the things it checks can just be the parser's AST, because this new node should be part of that at that point. Yes? Yes? I think. As long as we add the child first, it has access to everything, itself and the rest of the program. So I think that's right. I think that's right. So okay, parser. They pass the parser in here. Post pass. So update macro calls is connect types also have to do that. So for each node in the AST, connect types, parser child. Find type match for name upwards. That's gonna go up the, that should still work. That should just work. All right, let's just see where we're at. Better. Oh, post pass. This was actually broken before. If I don't do it for these secondary chunks, are we fine? No. Okay, let's just keep going through this. Update map. That's fine. That's fine. Let's connect decal refs. Is that fine? For each child of the thing we passed in, which is a source file, connect them, match upwards. Right, we just go up their parents all the way up. What do we use the parser for here? Oh, okay, that's fine. Yes, that's all fine. Oh, wait, did I move this down below? Oops. Right, this needs to happen here also. Okay. Okay, even better. But now we're getting redefinitions. Why? Oh, wait, we're getting redefinitions. Okay. Line 1 is not very good. Why are we getting... Why? Nope. Let's go back to main here. Let's remove all of these yet again. What did I do? Why did I do that? Okay. We compile. If I just do a single print, that should work fine. It's not even generating anything, but it is. Uh-oh. At least it's a simple case. Redefinition. Previously defined here. So that's when we're compiling. So let's look and see what we generated, huh? Oh, we're not actually spitting out the files yet. Let's do that. Here. Generate source file for chunk. We're going to do that down here. And we're going to just stick this up here. Okay. Contents equals generate source file, parser arena, and the output source node. If contents dot length to verify it's valid, we are going to write entire file. Contents output source node source file dot path. This is the info. Format string, short string, format string. There's the forward decal, there's the definition. Okay, we're doing it twice for some reason. Are these identical? Let's see. Are these the same thing? Let's clean them up. Okay, there's that one, and these look the same to me. which means if they're the same, there's less work to fix this. If they're different, something really strange is going on. Okay. Pen string. Okay. Yeah, they are the same thing. Result line. Yeah. Okay. So these are the same. It's getting output twice for some reason. Does our primary chunk look good though? ToString. Dynamic string, ToString. Yeah, these are only getting generated once, so what did I do? I definitely broke something. Generation queue. I'm probably... so we run it on... We're running the metaprogram on all of these nodes. And then if we generated more code, append that to the AST, run our post pass, generate the source file. So, and here somewhere, I think we're generating twice. Why are we generating twice? Default metaprogram. Okay, wait. Why though? Why is this happening? Let's do this. Let's go to add function decal to program. What is this calling? Add node to program, which is calling append child, which is calling add node to generation queue. Let's just do this. Let's just print out that every time we add a node. Let's do print AST node write output /n. Let's just do that. Let's see what's getting added. Okay, here's print, type info. Let's go to format string. Format string. Okay. Here's format string. It's taking in, or it returns a dynamic string. It's the one that takes in a short string and nothing else. Here's another one that takes in a short string and nothing else. So here's the two that it's generating. It's generating this one twice. I don't know why. Format string. Okay. And they actually have different pointers as well, which means this is in fact getting generated two whole entire times. Why? Format string, validate format string. Wait, where do I define that at? Is that in print? Yes. So it's probably in generate. How do you do that? Search identifier, Control T. No, wait, how do I do find? Oh, Control J. Function templates. Okay. Let's just do this. Hit format string. How many times do we hit this? We should only hit it once, because we call this once, which calls this So we should only have one of those that it sees the one time. Let's stop printing this out. Yeah, we hit it twice. Why are we hitting it twice? Let's... Ooh, this is too small. Stream can't see that. Okay. Let's see why this is getting called twice. This is in metaprogram. Hit format string. So, nope. Okay, we hit it one time, and we came from the default metaprogram. The secondary, right, this is only called from the secondary chunk because we don't call format string here. This generates a print function, and that print function calls format string. So we call it from that secondary chunk, so that makes sense. Okay. Oops. Wait. Let's back out. Back out. Okay, good. Yep. Remaining nodes is 68. Oh shit. Let's go past this. Oh, we're hitting it in the same pass? We're hitting it in the same pass. Why are we hitting it in the same pass? That doesn't make any sense. Why would we be hitting this in the same pass that we see it the first time? All right, let's do this. Let's go here. Let's not do this. We hit format string. Okay. We hit it a second time. Why? What? Remaining nodes are 68. So we're hitting it on the very last one. And the first one. Wait, what? Alright, I need to print out our generation queue, because that doesn't make any sense. Let's just print all of them. So while this current next print AST, or no, let's just print the node nicely. Cur generated node. Okay. Shit. Print node nicely should, whatever. It doesn't output a new line. That's not very nicely, but it's okay. All right. So we see print. Right, because we generated a print function, we generated a type info struct, we generated get type info. Wait. Right, we're going to get a get type info function. These aren't labeled very well. A bunch of get type info froms, a bunch of structs here. Type info from, boom, 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 boom. Format string specifier. We generated a bunch of toStrings. Great. Okay, so that's fine. Nothing looks weird there. But after our first run, wait. Wait, yeah, because then we run the metaprogram on. Hold on. We run the metaprogram on all of this stuff. And when we run it on this is when we should generate this. So I'm not understanding something right now. Wait a minute. Is that coming from... Oh, when I call append child. Oopsie. Append child. I'm adding... Oops. I'm adding this to the okay. I'm adding the thing that we just generated, this source node chunk, to the generation queue. Skip generation queue. So when we do this, don't add that to the generation queue. In fact, we'll say add to queue. Don't add this, and don't add this. Okay, we're running now, and you don't see two of these, and you don't see the chunks showing up in our generation queue. Great. Okay. Okay, so that's a to-do that I'm not sure is fixed yet, so we'll leave that in there. But so if I go to main, let's just try this bigger one and just see if it still works. It does. If I also have this, that's a weird one. Let's not do that yet. Let's print out the platform. Great. Let's print out these two. I have it to do in there. It says it causes a failure, but it doesn't look like it does anymore. Great. Does this work? I'm gonna guess no. No. So this still causes a failure. Remove this, because that's already on the to-do list. This is no longer relevant. Validate format strings. Format strings. To do at the bottom of validate format strings. I forgot I turned this off. Let me get this not working. What is this doing? Oh, this is the thing that actually stops. Okay, that's fine. Second one in generate function templates. This is only gonna hit. Okay, that's what that is. Okay. Okay, we'll leave that in there. there. Okay. This, though, that all works. I feel pretty good about that. And what does our file look like now? So we've got primary chunk and secondary chunk. So the primary chunk, this is fucked because, oh, I don't want to sort these. I don't need to sort these. Oh, shit, I just want to write this out verbatim. This should be in order. This should not be sorted. Or dependency mapped or anything. So, does that happen in here? Yes, it happens here. Generate type dependent source. Oh. Okay, I'm glad I redid this function, or I refactored it anyway, but I actually don't want to do this at all. This function's actually way simpler than this. Because all it has to do, all it has to do is generate type dependent source. Type dependent codegen node. Okay, this is more complicated than it needs to be probably, and it's going to make this a pain in the ass. But where am I at on these? So update the chunks. All right, this is not really relevant. We've kind of moved around a little bit, so that's fine. Man, so this is more complicated than it needs to be. Well, this stuff isn't, but I don't know if I have a good way to just write out this node to a file. Well, maybe I do. This isn't modifying line numbers. This is just moving stuff around. So handle conditional. What is that doing? Does that take codegen nodes? It does. Append node as maybe that doesn't actually matter. Maybe I can just write this out. Append node as string. What if I just do that? Does this take a source file at the top? Bro. Append node as string. Okay, maybe I just loop over everything and do that. That might be all I have to do. Let's just try it. Let's take this and this will be metagen string builder. Builder equals create string builder parser arena. We will say for each child node of the output source node, we will append node as string to the builder child. Output source node info source file path. Okay. Is that it? That may be it. Shit. Okay. This is stupid, but whatever. I'm making this harder on myself than I need to, but it's okay. Contents. Dynamic string contents equals build string builder. Okay. Oh my god. It's in order. I think that's all I had to do. And these should line up with what is in this. So if I just go to like primary chunk, line 55 of primary chunk should be this pound define. So if I go to line 55, oop. Oh, it is, but there's, why? Why is that happening? Well, first of all, let's get rid of the line directives because I don't actually want those. Append node as string. File path node exempt. Let's pass in line numbers equals true if line numbers and so we're gonna say here just no line numbers, and I guess we will just append character. Do we have a append string? We do have an append character. We'll just append a new line every time. Why not? Oh boy. Append notice is ambiguous. What? Do I have more than one of those? Oh, I have that forward declared somewhere. Yes. Oh, C++. Okay. Let's open this up. Let's open this up. Those still have line numbers on them for some reason. Oh, that's why. Oh, shit. Because all of these need... Oh, this is gross. I don't like it. What a pain in the ass. let's append string, append string, append string, append comma separated children. Does this do that as well? Oh god. Okay, let's not. Shit. Oh, I have set myself up for pain here. Disable lines global. All right, let's do it that way. Fuck it. Disable lines global is false. Does this still work? No, because this is no longer that. But before we do this, we're gonna say disable lines global equals true. Old global equals, this is awful. But it should work though, yes, okay. Jesus. So if we go to primary, line 55, if I go to line 55 here, does not line up. Where is this thing? It's right here, it's on line 83. Okay, so if I don't output all the weird new lines, what does this file look like? Ah. $55. Still no. This is what I was afraid of, because now there's a mismatch between. This says it should be on line 55 in the AST. But that doesn't mean. I feel like I'm gonna have to diagram this out to make this proper, because now in order for these things to line up, I'm gonna have to do some shenanigans when I'm doing the canonical record for what this should look like is in the nodes. They have their line numbers in the nodes. So okay, let's just do something real quick, real dumb, and just see if where this gets us. So for each node, let's do this. Let's say U64 running line number equals. Are those, do those start at 0? Yes, it does start at 0. Okay, so the running line number will be 1. So for each node, while running line number is less than child line number plus running line number, and we're going to append. I don't know if this is going to do anything, but we shall see. So if for whatever reason our first one happens to be on line 2, all right, let's just see what that does. I don't know what this is going to do. It might be super wacky, but let's delete. Well, I don't think that did what I wanted to do. Primary. So this is on line 55. No, not even close. Let's do this. Print node nicely child write output let's just do that. Let's just see what we're saying here. So this get type info is on line 55. True. So when I'm writing this out, well, let's look. Okay, print. Let's do this. What am I doing? Let's output this. Okay, print is on line 1. Another print is on line 10. Oh, because these are printing new lines inherently in between. Okay. That tells me something. This is inherently printing. Yeah. Like this, for example, is just inserting new lines in between these. Yeah, like these are all just that's probably fine. Yeah, like all of these are just, oh god, I don't know if this is gonna be, oh boy. Dude. This might be a bigger project than I'm ready to tackle tonight. Really wish that I would have thought this part through as I was doing it. But that's not where we're at. I need to Man, I'm going to really have to think through how codegen spits out this stuff, because right now this is untenable. Unless I update each node's line number here. That might be a stopgap fix. That would be a stopgap fix. So if I do this, right, and then this should at least be separating these into lines. Yes, and in fact, let me do another one just because. No, we'll just do 2 characters, it's fine. That'll at least give these guys some room. So you can go through all these things. So I should theoretically be able to say well, no, because I don't know how many are being written. Arg. Okay, I don't know if I can continue on this part tonight. I needed to do that lets me know what's going on though. there's a rather large to-do to tell me what needs to happen there. Okay. But we're at least back to working, and we have some decent we have some decent chunk files we can look at. So you can see the primary chunk generated all this code, the secondary chunk generated all this code. So our main, I call print a bunch of times. So my generated code had to generate all these print functions, but these print functions call format string. So on our second round, we generate all these format strings. Great, and we can see that clear as day in the source. So that's kind of where I wanted to be at here at the start, which is great. This other stuff is going to be a lot trickier though, so we'll have to come back and think about that more thoroughly. But yeah, I'm very happy that this stuff all works now. And yeah, I may call that. Let's see. So let's get rid of our Scratch files and let's add, actually, let's see. Wait, we must be generating that gen directory, otherwise it would have failed, right? Yes, we are. Okay. So let's go ahead and add this. All good cleanup and prep for more. And we're gonna say generating code in chunks that we now also write out to files. Okay, great. Cool. Well, surprised some people actually joined and watched and even followed, so hopefully I can keep doing this. That's some good motivation. So thanks for watching, everybody.